Question 1.2.1 states, sketch the graph of log 2 y equals x and its inverse on the same set of axes. So I know I'm going to have to draw one graph as well as its inverse on the same set of axes. So before I start doing calculations, let's first find the equations of my two graphs. So the first thing that I'm going to do is, generally when we have graphs, it tends to be in the form of y equals something, so I can see whether or not I can do my log in a different format, my equation in a different format that might be easier for me to work with. And what I can see is on my formula sheet, the very first formula it gives me is how to change between my logs, my exponential form, to my logarithmic form. But what I know will happen is the 2 that is suppressed will come over to the other side and press the x up into the air, meaning that if I change this from a logarithmic form to an exponential form, I'll be left with y equals 2 comes over and it presses the x up into the air. So this will be my graph that I'm going to draw. So again, that is just to simplify it so that it is in the form of y equals. Now the second question states for us the inverse of the graph. So for an inverse of a graph, we said that we change the position of the x and the y, and we make the y the subject of the formula again. So that will, if we look at it, take us to a very similar place. So we're going to swap the positions around first of all, which means I'm going to have x equals to 2 to the power of y. So I just swap the position of my x and the y, and then I want to make y the subject of the formula, as I did with the first equation that was given to me. So the y is now in the air on this side. I need it to drop down. So for it to drop down, we're going to end up with a similar situation like this, but the 2 is going to come back to a log, and the x is going to be here, but it's going to be y on the other side. So it's going to be log of x, which we know. However, the 2, which is big on this side, will now become a small little 2 down there, and the y, which is in the air, will drop down. So these are the two graphs that we will be drawing. So we're going to draw the logarithmic graph, again similar to the first one, and we're going to draw the exponential graph on the same set of axes. So with exponential graphs and logarithmic graphs, if you have memorized how to draw them from just looking at the equation, it's good. However, again, if you're not sure, you can use the x-intercept, y-intercept method, and then the table method after that. However, noting that if we do the calculations, we'll see that the log and exponential graphs does not always have both intercepts, as it sometimes does not cut through the axis. So let's look at the first equation, so the y equals 2 to the power of x, and see if I can do its intercepts. So if I have y equals 2 to the power of x, and I say I want my y-intercept, so for my y-intercept, I know that I'm going to say x equals to 0. So in other words, it's going to be y equals 2 to the power of 0. And we know that anything to the power of 0 is going to be 1. And again, if you type that into your calculator, it will confirm that my y-intercept is 1. Then let's see if I can do an x-intercept. So for my x-intercept, I will have y equals to 0. So I will have 0 equals 2 to the power of x. So generally our rule was that if you have 0 and my x is in the air, you will not get an answer for this. However, we can test the calculations. So what I need to do is I need to drop my x off to the ground so that it is not an exponent but rather a base. And to do that, we're going to do logarithms again. So with logarithms, the other side will get a log in front, so it'll be the log of 0. And then the x that's in the air falls to the ground, and the 2 that is big will go to the side. And you'll see if you type log 2 0 into your calculator, it will give you a math error. You can type log of any base 0 or ln of any base 0, so ln 0 or log 0, whether it's base 10 or base e, both of those will still give you a error since we cannot calculate this, meaning that my first graph will not cut the x-axis. So then the next thing that we'll do is, let's see if we move over to our other graph, if we can determine my x-intercept and y-intercept. So now I'm looking at the graph of log base 2 of x equals y, and I see for my y-intercept, I'm going to say that x equals 0. So again, if I replace in, it's going to be log base 2 of 0 equals y, and we know that we cannot do a log here, it will give me an error. So again, both of these will not work out for us, so it does not cut, this one does not cut my x-axis and this one does not cut my y-axis. So then the next step was the x-intercept of this graph. X-intercept. So the x-intercept will then be the log of 2x equals y, which is 0 if I'm doing my x-intercept, equals 0. And then what will happen is we're going to do exponential form again. So the 2 will come over, press the 0 up into the air, and the log will fall away. So it's going to be x equals to 2 to the power of 0, which anything to the power of 0 will give me 1. So I know that if I draw my axis for my graph, if I do that, just sketch a rough axis for the graph in there, I know that my green graph is going to not cut my y-axis. So it's not going to cut the y-axis, but it is going to cut the x-axis at 1. So it's going to cut x-axis where the value is 1. And I know that my blue graph is not going to cut my my y-axis, or it's not going to cut my x-axis, but it's going to cut the y-axis at 1. So in this scenario, we were not able to sketch the graph completely since we only have one point. So the x-intercept, y-intercept for logarithmic and exponential form might not work out as good for us, as we do not have at least 2 or 3 points to get the general shape of the graph. So in this case, what we're going to want to do is to do the table method so that we can get at least 1 or 2 more values to see, does the graph go lower or higher at certain points. So if you do the table method, you can just select maybe 1 or 2 values, add them to the table to get your coordinates, and then use those coordinates to sketch our graph. So you'll note that if we do that, you'll end up with a graph that starts small, always nearing the axis, the x-axis, but never quite touching it. And if we use the table method for the exponential graph, or for the logarithmic graph, sorry, so that will be my exponential graph, and then for the logarithmic graph we will have a similar situation where it will near my y-axis but it will never touch it. And because these two graphs are inverse functions of each other, it means that they should, if drawn, be symmetrical about my y equals x line. So they should be symmetrical about that, meaning that if I fold it on my y equals x line, they should be symmetrical. So if you fold on it, they should lie on top of each other. So that is then question 1. So again, I'm not going to draw out the table. So whether you do the table method for drawing a graph and physically drawing the table or using your calculator, any method will be fine. What's important for us is to indicate our intercepts, as we will get marks for that, and you'll get marks for the shape of your graph as well. So make sure that you at least get your shape by doing the table method. Okay, so that was question 1.2.1 was sketch the graphs. And then 1.2.2 says, with respects to which line are the graphs asymmetrical? So again, it's very important when we do these types of questions to look at the word symmetrical and note that if it's asymmetrical or whether it says symmetrical. So in this case, they say asymmetrical. And that means about which lines is it not symmetrical. So we said it is symmetrical about my x equals y line, and that's the only line about which it is symmetrical. So it is asymmetrical, these two graphs, in relation to each other. They are asymmetrical about either, we can say, the y-axis, we can say the x-axis, since if we fall on this line, it is not symmetrical, and if we fold over the y-axis, it will not be symmetrical. So for that question, we can say the x-axis, and we can say the y-axis. So again, mentioning any one of them will give us our marks for this question. Then it says 1.2.3 is the graph of the inverse of log 2y continuous. So it asks us if the inverse log is continuous. So again, we said with continuous, it means as soon as I put my pen down and I draw the graph, I can draw the entire graph without lifting my pen. So I drew it one continuous motion. So in both of these cases, they are continuous graph, since we did not have to lift our pen up to draw them. So is the graph continuous? And we can say yes, it is continuous. That is question 1.2.